Okay, so today I'm going to be talking about the knapsack problem, which is a problem where you have a bag that has a maximum capacity in it and you have too many items to fit into the bag. So say we were going on a camping trip and we had a bag that had a capacity of 5 pounds and we wanted to take these 3 items with us. Well, we couldn't because their total weight added together is 6 pounds. So notice here that each of the items has a weight and a value. So some of these items are more valuable for the trip than others. So what we want to do is figure out what's the best combination of items that we can fit into our backpack that will give us the most amount of value. So for us as humans, it's easy to see that picking the Eno and the collapsible water bottle would provide us with the most value and it would fit inside the backpack. But for a computer, it's more difficult for it to find the solution. So I'm going to take you through a quick algorithm called the Knapsack dynamic programming algorithm that a computer can use to find the solution. Its efficiency is big O of NC, where N is the number of items and C is the capacity of the bag that you have. Bag, suitcase, whatever. Alright, so here I've written some stuff down. I'm just going to take you all through this problem now. So I got a lot of stuff going on here. I've got this massive looking formula up here. I've got a key right there, a matrix right here. And so I'm just going to talk about a couple of these things and teach you all about this algorithm. So right here I've got a 4x6 matrix, right? And the reason that it's a 4x6 matrix is because the number of columns needs to correspond to 1 plus the capacity of the bag that we have. Okay, so 1 plus the capacity. So we have a 0 pound column, and then we have a 1 pound column, 2, 3, 4, and a 5 pound column because our bag has a capacity of 5 pounds. All right, so then we have 4 rows, and the rows correspond to the number of items that we have. So we have 3 items, so we have a 0 column, and then item 1, item 2, and item 3. Sorry, I said column. Item 1, row, 2, and 3 row. Okay? So the objective of the algorithm is to fill up the matrix. Okay? So once we've done that, once we fill up the matrix, the answer to the problem will be found in this bottom right box right here. So let's get to it. Okay, so the way that we're going to fill this matrix up is we're going to start with this box right here. So you start with the top left box that doesn't have a 0 in it, and you move to the right. And once you get here, you just start in the next row and move to the right and move to the right to fill them all up. So the way we fill it up is we use this formula up here. So what this says is F sub I sub j. So I is row number and j is column number. So if we wanted to fill in this box, we would say F sub 1 sub 1 is equal to, and then we'll work through this formula. Okay, so let's just jump right into it. First thing you should notice is up here we have 2 scenarios, right? So we have where j minus wi, where wi is the weight of the item number, is greater than or equal to 0, we have to do this stuff. And then we have if j minus omega I, or wi, is less than 0, we have to do this stuff to fill in the box, okay? So right here, for when it's greater than 0, we have to find the maximum value between these 2 things, right? So there's a comma here, sorry. I don't know if you can see that. But this first scenario is f of I minus 1 of j. And the second scenario here is the value of I plus f of I minus 1 of j minus wi. Okay? So let's just go ahead and start to see if we can use this formula to fill it out. Okay? So if we wanted to look at f of 1 of 1, okay, so that would be this box right here, right? We're starting in f of 1 of 1. I guess I shouldn't put a 0 in there. F of 1 of 1 is equal to what? Well, I've got a key down here, right? So I know my I is equal to 1, my J is equal to 1, my WI, since we're on the item number 1 row, is equal to 3 pounds, and my value of I is equal to 4. Okay, so to fill in this box, we're going to have to use this formula up here. So first we need to check what J minus WI is. Well, J is 1 and WI is 3, so 1 minus 3 is negative 2. That means that since negative 2 is less than 0, we have to use this formula right here. So whatever we're going to put in this box is equal to f of I minus 1 of J. Okay, so I is equal to 1, so 1 minus 1 is 0, so f of 0, and J is equal to 1, so 1. F of 0 of 1. Well, we're going to put in this box whatever is in f of 0 of 1. So we go to row 0 and then column 1. And inside that box is a 0. So we're going to put a 0 in this box. Okay? Then, all we're going to do is we're going to increment J, right? So we're going to add 1 to J, which would make it a 2. Okay? So we need to figure out what's inside of f of 1 of 2. Okay, so first we need to figure out what J minus WI is. J is 2, WI is 3, so we have 2 minus 3, which is negative 1. So it's negative 1 is less than 0, so we follow the same formula that we did for this box. So I is still 1, so 1 minus 1 is 0. J is 2 now. So we're going to put whatever is in f of 0 of 2. F of 0 of 2 is a 0. So we're going to put a 0 in this box as well. Then we need to increment J again. It's going to be a 3 now, right? So start here. J is 3. WI is 3. So now 3 minus 3 is 0. So we have to use this top formula now. This is where things get a little tricky. So for this top formula, we have to find the maximum of these two things. Well, we need to figure out what those two things are first. So f of I minus 1. I is 1, so it's f of 0 of J. J is 3. So f of 0 of 3. Okay? F of 0 of 3 is 0. So this one's a 0. This one, f of I minus, or vi plus f of I minus 1 of J minus WI is what? Well, vi is 4, right? Vi is 4, and then we have to add to that f of I minus 1 of J minus WI. Well, I is 1 still, so 1 minus 1 is 0, J is 3, and WI is 3. So f of 0 of 0, right? Because J minus WI is 0. So f of 0 is just 0. So we have 4 plus 0 over here for this one. Well, the maximum of 0 and 4 plus 0 is 4, right? So we're going to put a 4 in this box. Okay? Now, we're going to move on to f of 1 of 4, which takes... So as you can see, the algorithm takes a minute for a human to do, but computer, the efficiency is big O of NC, where N is the number of items and C is the capacity of the bag. So it'll do it a little bit faster than we can. So let's see here. We need to increment J. So J is now 4, right? J is now 4. And hopefully you could see how we could program this with some for loops and some comparative statements in C++ or whatever. So we need to check what J minus WI is. J is 4, WI is 3. 4 minus 3 is 1. So something you should know, once you get to where, if you're going across a row, once you get to the box where you first have to start using this top formula, you're going to have to keep using it until you make it to the end of the row. So you really don't have to check J minus WI, right? Because J is always going to increment as you go to the right. Okay. So like in this next row, if I say I start using it right there, then I know that say I start using this formula right here, then I know that each of these boxes will use that top formula as well. Okay, so okay, we need to find the max of these two things. F of I minus 1, I is 1, so 1 minus 1 is 0, j is 4, so f of 1 of 4. F of 1 of, oh sorry, f of 0 of 4. F of 0 of 4 is 0, so this one's a 0. The value of I is still 4. And this one, f of I minus 1, f of 0 of 4 minus 3 is 1. F of 0 of 1 is just going to be 0. So we've got a 4 here again. And I could take you through all of these, but that would take a long time. So I'm just going to fill in some of these. If we were to continue doing this, right, this one would be a 4. Right? Now this next one right here, we would decrement, or we would decrease j back to 1, right? J would become 1, right, because we're in column 1. And I is now going to change to 2, right, because we're in row 2. Right? So I'll take you through this one, and I'll fill out some of these. So this is going to be 2, and this is going to be 1 now, right? So now that we've started a new row, we don't know which of these we're going to use, so we need to check what j minus wi is again. So j is 1, and wi is 3. So 1 minus 3 is negative 2, which means we use this bottom formula here. So I is 2, 2 minus 1 is 1, and j is 1. So we need to put in this box whatever is in f of 1 of 1. Okay, so 1 of 1 is 0. Oh, and I wrote a 1, even though I said 0. Anyway, so if we would continue to do this, we would place a 3 here. 4 would end up going there. A 4 would end up going there. A 7 would end up going there. And so on and so on. Here would be a 1. Here would be a 3, 4, 5, and then I'll do this last one here. And the process does not change. It does not change through each of these squares. So we can just keep doing it. So if we wanted to figure out what was in this last box, I is going to be 3, and j is going to be 5. So we got a 3 here and a 5 here, right? J minus wi is 5 minus 3, which is 2. So we're going to use the upper formula right there. So we need to find the max of these two things, right? So f of I minus 1, I is 3, which 3 minus 1 is 2, and j is 5. So f of 2 of 5. So f of 2 of 5 is 7. Okay? And this one here, v sub I, so our v sub I now, sorry, I should have been changing these throughout the video, but as we move from row to row, w sub I and v sub I change, right? Okay? So, might have done something wrong here with this one when I showed you how to do this one, but it is supposed to be a 0, and this one's a 3, 4, 4, 7. But yeah, so we're on item number 3, right? So the weight of item number 3 is 1 pound, and the value of item number 3 is 1 point. Okay, so, alright, we're up here. So we found that this was a 7, right? And now we need to check what this one is. So v sub I is 1, right? And f sub I minus 1, I is 3, so 3 minus 1 is 2. F sub 2, sub j is 5, and wi is 1, so 5 minus 1 is 4. So f sub 2 sub 4. So what's in f sub 2 sub 4? So we go to row 2, column 4, we found that's a 4. So this comes out to be 5, right? So the max of 7 and 5 is going to be 7. And as you can probably tell from our little note cards here, that is going to be our answer.